Hello everyone, and welcome to this new tutorial on Grasshopper. Today I'm gonna teach you how to create a terrain model from a DTM using Bison plugins. So if we go to the website of Bison is a landscape architecture plugin for Grasshopper and Rhino 6. You just have to log in and download the latest version. Go to Rhino, go to the special folders and components folders, and go to libraries and copy there the Bison GHPY file and restart the whole software, and everything will be work properly. In a previous tutorial that you can find in my YouTube channel, I explained how to import terrain with Docofossor, which is another plugin that is very useful as well. The difference with Docofossor is Docofossor import the terrain using a completely different set of files extensions. So these use ASC or ASCII or DF or XYZ. That's the big difference. So Bison, in fact, is uses a GeoTIFF or TIFF file. Okay, so the first thing what we're gonna do is to import. Just going to add this mesh. There are different analysis, annotation, mesh resample sections and editions. I'm gonna cover these in different tutorials in future. So we import this mesh. We need first a file path, and we need to define a file path. Okay, and we need a sample. So for the sample, we need a number. I did some tests before, and I recommend, depending on the resolution of your grid or your GeoTIFF, sometimes the GeoTIFFs are completely very big and in size. So I recommend to start with a lower number of sample, which is basically the factor as the Nordic scale to read. So it's the inherited value is 1, but I suggest to use 5. So you can start decreasing, and then so it doesn't take too long for your calculations. And then we need the X and Y dimensions, which is the dimension of the pixel. So for the pixel, let's imagine we can use maybe 10 meters. Let's do this. We can use 0, 10 meters, 20 meters. Okay, and we can use this for X and Y. So for the file, if you have open QGIS, you may have different type of files. In this case, I have an ASCII file I added here, and I want to convert this to a TIFF, a GeoTIFF. To do so, you just go to the raster tab, go to conversion and translate. Here you have the information of the DTM. You need to find a projection. I have this saved. If not, you just can use any one from the list. Then set up the no data value. In this case, I put no set. And then choose the file type you want to save it. You can save it as an ASC or GeoTIFF, which is on top of the list, and then use a name here. In my case, I don't need to use a name because I already have saved one of those. And then you just put run, and this is automatically saved. So back to Rhino. What we need to is just to put as a solution here geometry. In fact, this is the geometry. So what we can use is simply a mesh or a geometry. And so now what we can do is just add the file, set one existing file. So we go, I already have some information here, some files. So we use for this TIFF, look, we open it, and we just wait for this program to run it. So that's what we have. So we have a quite flat, because it's quite flat, the surface, so it doesn't visualize very well, but well, it is exactly the GeoTIFF. So perhaps I can replace this with another geotiff. Let's see, the DTM one. Why not? Open, and let's see how it goes. Okay, so that it is. Now, what happened here is that I noticed that this terrain is exaggerated because it increased too much the x and y dimension. This is a multiplier, so it's something we have to correct. We just simply delete this, and we can leave it as it is, look, or we can simply up the number here, number 1, which is the size of the both dimensions. Okay. So as we reduce the sampling, it increases the resolution and also the processing time of your mesh. Now, what I would like to do is just export this mesh into Rhino. But you can also create a custom visualization, which is the best. So we go for custom preview, block the geometry, and then you choose the material with a color swatch. You just need to go a little bit down. It's a good color. That's it. So once we have done this, we don't need to visualize any of this. So now we can bake this mesh and send it to the default. I don't have any other layer. So as you can see, they use a triangular irregular network or a triangular mesh, which is highly detailed. And so we can really change the sizes of the meshes in order to improve the calculation time. So how we can do this? We use these meshes. We can remesh random, we can remesh square, and we can remesh triangular. The logic is pretty simple. It's very similar for all of them. We just need the mesh. We already know here. We need a grid, which is the number of the size. So let's use with a random, and let's use triangular for now to compare. We just can move this one here. So we use the mesh information in both of them. And we can hide this connection to make much cleaner the view. And we can hide again. When you move it, you can find the connection of it. Okay. Now what we need to do is create a dimension for the sampling size. So in this case, if it is 2 meters, I want something much coarse. Let's say 30 meters. So this will be my grid and will be generate random sizes. So I want to turn off this. And then what I can do is I can come with my custom and connect the mesh directly there. So you can see it's much smoother. Okay, so you lose resolution, of course, and detail. This randomly generated. Now, if we bake this, and we go here to bake, so you will see here the triangular network has been randomly selected. Now let's do something similar with this one. We have the mesh, we have the grid, we have the 30 meters as well. Connect there. So what we do is move this and connect here. Okay, and we turn off this, and we turn off this. So it's a similar kind of resolution, but it's completely different in terms of if we bake it, it's a completely different calculation. So it's more regular, use triangular irregular networks, and they are equidistant, 30 meters distance. So it's completely different than this one. So this is more irregular, it generates different type of triangles, size of triangles. So this may have an influence if when you do different type of analysis. So you need to be aware of these differences and be careful about them. Then we have other method for remeshing, which is using the Lunchbox. So if you install Lunchbox, and you can go to Food for Rhino and install it directly from there. So we can go here, Lunchbox. Then we go for Food for Rhino. Here is here. The installation is slightly different. You just follow the instructions. You just have to copy all the latest version of the Lunchbox has .msi file that is a kind of installer. So you just need to run that, launch that Rhino Grasshopper. Just click once, only the installer. It will deploy everything automatically. Okay, so it's a different method. Once you have the Lunchbox, you can go to utilities and mesh reduce. So let's imagine we're put it here. Okay, so this one method, mesh reduce, is another method. So again, we need the mesh. We just connect this one here, bypassing. Let's take a little bit. What I recommend to avoid is processing time. It's sometimes better just to start with the parameters of the target, the accuracy, the sizes, and the distortion, and after that connect the mesh, because otherwise we'll assume the default ones and it will take time. So if we disconnect here and we start just defining the target size, so here you need to check this information. You have here a mesh of 250,000 tiles in one direction and nearly 500 in another direction. So your target size is much smaller. Say it's 2,000 here, but let's imagine we put 5,000. You will see the differences. Distortion is if there is going to be a distortion, this type of distortion, and we say true. And the level of accuracy, we can leave it there as 0, more accurate, and 10, less accurate. So let's put, let's say, 0 is less accurate, number 3. And this is the target, the distort. We leave it at normalized size. We just leave it as it is, as false. So now what we do is just we connect this mesh, and it will run the process. As you can see, it's taking a little bit longer, the remeshing or reducing this mesh, because the processing method is different. So what we do is now we can bake this, go back to the default. So you will see a completely different, a completely different mesh. And the method here is completely different because it's in somehow it's less detailed than this one. It's more detailed than this triangular irregular network, and even than this one. But it has much less number of tiles. So if you see them this in an Arctic, you can notice the difference. So this preserves some level of detail, while these two are losing some level of detail. So you see this interpolation that is a big awkward, and the same here. And you will be able to run a lot of new, let's say, other type of analysis and connect with other plugins in this way because it's really fast. Now, in a previous tutorial, I'll also use Docofossor. So what we can do something is like you can also connect the Docofossor to these meshes. So that's what I'm going to do here. Let's imagine here, moving here, and I will do the Docofossor. I'm going to import ASCII. I need again a file path, connect there. And I will know that sampling method. I will put it in 2 or something similar to this, exactly similar. Okay, so this is the pixel size, and the rest, the other information is exactly as I mentioned, the origin. So we don't need this. I will set up the same, which is the DTM one. SC DTM one. Okay. So will take a bit. That's it, and then we're gonna need to shift the grid. And once we have done that, let me just bring this one here and turn off this one and connect here. So we need here a mesh. So we create a grid mesh and we connect the grid mesh to the geometry. And here is something interesting that I wanted to show. The Y represents the north, so it's the true north. So if you go to the QGIS, you will see that these sort of creeks are flowing from the southeast corner towards the northwest corner. And so when we imported from the Docofossor, you got the correct angle. Okay, the correct orientation. Notice here where it's completely rotated in the case of the Bison. So this is something you need to be very careful if you're going to run aspect analysis. Okay, or if you want to run some microclimatic analysis with Ladybug. So in fact, to solve this, what we need to do is rotate the Bison mesh before continuing with the rest of the exercises. So what we have to do, in fact, is rotate. Okay, so how we do that? Simply, I eliminated this mesh geometry here, and we just right-click, and we put rotate. So what we're gonna do, let me move this one here. So what we do is now we grab the geometry and we have to rotate it. Okay, let me turn off these visualizations over here for a moment. So what we're gonna do is rotate this. See, or it's good to have this one on just to show what it is the correct angle. So we rotate this one. So now which angle of rotation? Let's eliminate it. Oh, sorry. So this is the original there. There's not that much difference, I think. So you see here the rotation. So what we need is to have this pointing up. So what we can do is just change the angle. The angle originally is 0.5p. What we need is just this one here. So we're going to start with a panel. And we can right click there and put minus 0.5 multiplied by p. And see how it works. So what we have here, the center has changed, but the angle is the correct angle. And the plane is the XY because we are rotating in the XY. Otherwise, you will change here to YZ, which is not what we need. So this is corrected. And from this geometry, we just can connect with the rest of the steps we have done. So now let me move this one here and connect this geometry to these meshes. Okay, and this geometry to this mesh. So now we turn off this visualization and we turn off this visualization. So what we can do is also from this mesh connect to the reshape mesh. So now we have the correct angle, we rotate it. So when we do the analysis, is the correct one. So there are different ways that we can now create this custom preview. So when we make these ones, they should be in the correct angle. And so we're going to do a quick trial. And so they are now in the correct angle. Look. Okay, so we don't need this anymore, but I'm gonna delete them. Okay, so now we have this, which is this mesh. This is the Docofossor mesh. Okay, we want to know geometry, which is a geometry of 250,000 vertices and 249,000 faces. We want to reduce the number of faces, right? So what we're going to do is we can copy one of these. Just copy. And so we just need this mesh. So we just plot the mesh there. Okay. Once we have done this, we can grab this customized preview and put it there. As you can see, the Docofossor has reduced considerably the number of faces. And if we bake it, you will see here the triangulars, irregular network. So now we're doing the same. We can copy this one here. Was a mistake. I should have disconnected first. Anyway, so it's calculating again. So it's here. So I just disconnect this, correct, and copy with this and with this. So that is the other method here, down here. Just let me move this one here. This we can make it. It's okay if it's not. It's okay if it is not. It's like this. So now we're gonna do the same. We're connected there. So the mesh here should be a reduced mesh, but with a higher level of detail. So we're using here Lunchbox, and we're using here remeshing tools from Bison. This is from Lunchbox. Okay, so let's wait a little bit. It's there. And we can bake or visualize this one. So you see here the visualization is just slightly better. And we can bake this. So you see the results. So at the end, the results are the same, but you need to be careful with the Bison importation. It uses first a different, where is Bison here? Bison uses a GeoTIFF. Meanwhile, Docofossor uses an ASC or XY or DF file. Second, Bison rotates the grids or the tile, so we have to correct this rotation before proceeding. And so we can compare it against the QGIS, in QGIS against the TTM there, to know what is the right. Assuming that the Y axis here, it's aligned with the north, okay? And then we can remesh both type of meshes with either remeshing components in Bison, or we can use the Lunchbox components. So that is all for today. Thank you.